Okay, so the vertex for this is a parabola. It's quadratic, and we learned the vertex was at h comma k. First one you find is h. How did we learn to find h? Who remembers that formula? Negative b over 2a. So if this is a is 1, b is 10, and c is negative 9. So then we would go negative 10 over 2 times 1, which is negative 5. This being multiple choice, just by getting that far, in 5 seconds, I've narrowed down my choices to 2. So I can at least take a 50-50 guess if I wanted to. But if you didn't want to guess, you could now get that negative 5 and plug it back in for all the x's in order to find k. I know some teachers that teach it that way. I know some teachers that teach the kids to put everything in the calculator all at once. Where they're going to run into a brick wall, though, is when you take the EOC, the calculator is on the screen, and it's not that type of calculator where you can store numbers in it. They're going to have a very tough time. Like when I ask kids to take book bags off their desk and stuff and they leave them on. It's going to be a tough time. The sky is falling. Oh no, building's on fire. Hey Jay, what's up, man? Yeah, you got your book bag on your desk. Thank you. So if you don't want to do it that way, remember I showed you that shortcut, synthetic substitution. Where k is going to end up here. Drop the 1, then you multiply, or every time you're multiplying with this number to get above the next line, then you add again, then you multiply, then you add. So that tells me that it's going to be the vertex is at negative 5, negative 3. Any questions there? This function represents the height of an object from the ground after some time. And they tell you what V stands for and the A stands for. Actually, I think that's going to be important because they tell you that A is 32. You can't miss that. A baseball player hits a baseball 4 feet above the ground with an initial velocity of 80 feet per second. Let's go to the question, which is about how long will the baseball take to hit the ground? Okay. So S is the height of the object from the ground. So we want to know when this S of t, we want to know if you're on the ground, how high are you off the ground? When you are on the ground, when the object is on the ground, how high is it off the ground? 0, yeah, 0. So 0 is going to equal the V. And they tell you that the initial velocity is 80 feet per second. So 80 would be where the V goes. Times the T, which is that's actually what we're looking for. How long will it take? So we want to know T. Plus H. H is the initial height. Yeah, but I just want to make sure that what H is. No, I see the 4 here. I'm looking up at the top to make sure to see. I want to make sure that H is the initial height, but I guess it is. I don't see it, but I guess it could be. So plus 4 minus 0.5, and then here's the important part where A is 32 because it told us that, and then T squared. If I simplify, okay, what is negative 0.5 times 32? Negative 16. I'm going to write that first because I want to start writing this in standard form. I can't do anything with the 80t, even though my t's look like pluses. So that's 80t, and then at the end, plus 4. So what we have here is a quadratic equation. What are the 2 most common ways of solving quadratic equations? Factoring and quadratic formula. The nice thing about both of those is that they require you to make the equation equal to 0, which we already have. Now, just some advice. When I see this about here, this implies to me that I'm probably gonna have to round, and that shies me away from factoring. Because factoring only works if your solutions are gonna be rational. And I'm guessing that if this had rational solutions, that it wouldn't be telling me about. So I'm gonna use quadratic formula here. Let's write it down just in case we forgot. X equals negative b plus or minus the square root of b squared minus 4ac over 2a. I believe that is on your reference sheet though. So my a here counts as negative 16. My b counts as 80, and my c counts as negative 4. I'll give you a little hint also. As long as you have a 0 on the other side, which we do, if you want to avoid this being negative, which you can still get away with it, and I'll show you that it works with quadratic formula. But if you want to avoid that being negative, you can change the 16 to positive, but then you got to change all the other sides too. You're allowed to do that. I can make the 16 positive if I make the 80 negative and the 4 negative. By the way, did anybody, I sent the emails out again yesterday with the results, and you got the trick down because you're using the school email. Did anybody else figure out how to use the school email? And then you get if you use the school's email when we do these practice tests, at the end I can send you the results and it'll tell you which ones you got right or wrong. So, and I'm not looking for x here, I'm looking for t. So I'll write t equals negative b. So it'll be negative 80 plus or minus the square root of 80 squared minus 4 times negative 16 times 4 over 2 times negative 16. T is equal to negative 80 plus or minus the square root of 6,400. There's two negatives, so I'll put a plus, and I believe that is 256 over negative 32. So T is equal to negative 80 plus or minus the square root of 6656 over negative 32. Now I'm going to guess that that number is not a perfect square. It is positive, so I know I'm supposed to get two solutions, but because they were using that word about, and am I correct, is it not a perfect square? Okay. Now another thing I know, this is why I don't like, even though negatives work with A, this is why I don't like people make mistakes with sign. Even I sometimes make mistakes with sign. What's the last operation I'm going to do here? If I were to follow, I know I'm going to have to round because of the fact that this is going to give me an irrational number, but if I follow order of operations, what's the last operation you're going to do really on any fraction? The division, yeah, on a fraction, the last thing you're doing is a fraction bar. And what type of number am I dividing by? I'm dividing by a negative, but what am I looking for? What does t stand for? Time. Can anybody here go back in time? So I know what's going to happen here is that if I get any negative solutions, I'm going to consider that to be extraneous. It just doesn't make sense in the context of what I'm looking for. It doesn't work, right? So if I'm dividing by a negative, but I know that I can't get a negative, what type of number am I going to have to get on the top? I'm going to have to also have a negative, yeah, because negative divided by negative is positive. So, who knows? Maybe they both give you negatives. I'm not sure. And can you give me a calculator? What approximately what is 6650? The square root of 16. Oh, because you have math, right? I wanted a decimal approximation. Approximately what is the square root of 66? 81.5. Okay, so the fact is it's greater than 80. It's bigger than 80, right? So if I were to add that, to negative 80, I'm going to get a positive. And if I divide a positive by a negative, that's going to give me a negative. So I'm just kind of like, I mean, you can go ahead and do it, but I'm just trying to save myself some time. I'm only going to focus on the negative part. So can somebody in their calculator just put negative 80 minus square root of 6656 and divide by negative 32 and tell me what you get? I think I have to do all these myself, so I'm almost certain from memory that I ended up getting 5. I'm pretty sure it's gonna give me D. That was the answer, but let me know if anybody's getting anything different than that on the calculator. Is that what you got 5? Approximately, it's close to 5. Does anybody not know how to get that on the calculator and you want me to try to help you? We've talked about the type of calculator that I'm assuming you're gonna get on the EOC is a one-line display. Now I don't have one-line displays to give you, but if you've ever seen like these before, I think I have one here somewhere. See, like none of you have this, and there's a difference in it because this one doesn't have a blinker. It's a little bit, it can be done, but it's a little bit harder to put multiple operations in here. So if this were the case and I was getting something like this, I would take the square root of 6, because you're not going to get an actual calculator, but the one on the computer I'm assuming is going to be of this type. It's a one-line display instead of a two-line display. Like the one that you have, the display that you have has 2 lines, so whatever you're typing comes out here, and then the result comes out like underneath. It's a little more user-friendly. But I would take the square, and here you got to hit 66, 56 first, take the square root. That's going to give me 81. Okay. Now here comes the tricky part. How could I put a negative in front of that? I would multiply by -1, because if I multiply by -1, now that makes it negative. So now I have a counter for this negative here. Then I would either add -80, or you can just subtract 80, which gives me about -161.5. And then I would divide that by 32. On these, the negative you got to put afterwards. I don't know how to work on the computer, but so you should have had about 5.04, 5.05. About 5 seconds. Which statement best describes how this graph compares to, okay, so transformation. I told you this was the first test where we started to kind of blend into the second half, like now that we've been all together. This is something that we have done together here with transformations. So if g of x, the only difference is that it has that -3 in front of the x squared. When you multiply by a -3 in front there, what is that doing? Vertical stretch, because the 3 is bigger than 1, but what does the negative do? X-axis reflection, and that's happening to g. So the graph of g of x is a vertical stretch. Okay, so A doesn't include about the reflection. B only talks about the reflection. This is not being shrunk, it's a stretch. So the graph of g of x is a vertical stretch by a factor of 3, and then x-axis reflection, so it has to be D. A only had the stretch, B only had the reflection, C was just completely wrong, or at least, well, it did have the reflection, but it was a shrink and stuff. We didn't call it a shrink. What did we call it? A compression. What is the end behavior? So look, I know that function looks really funky and stuff, but you don't have to really do anything with it. There's not much to do with it. You have to understand what type of function it is. What type of function is that? Quadratic. What do quadratic functions look like? Parabolas, and a parabola is either going to face up or it's going to face down. Which one is this one facing? Down, because of A is negative. So this parabola would look something like this. And we know that when we talk about end behavior, that's what the ends of the graph are doing. What are the arrows doing? What are both of these arrows doing? Pointing down. So I believe I showed you how to call this, like, down and down. But that's the easy way to refer to it. But then we also talk about arrow notation, right? So this means that the left arrow is pointing down and the right arrow is pointing down. Okay? Left and right means x. Left means x is going negative. Down means f of x is going negative. Right means x is going positive. Down means f of x is going negative. So which one is saying, so let's see. as x increases, f of x increases. Well, that's not true. Like anything that has f of x increasing, I can already get rid of it because I know all the f of x are decreasing. So look at this. I don't even need to try that. It's b. This is the only one that has both y's going down. Down and down. Use this graph to answer the question, which function is shown on the graph? Okay. Based on what's being highlighted here, what did we call those? Okay, well that would be the obvious one, to call it an x-intercept. But what else did we call them? Zeros. Say it again? Okay, yeah, you could call them solutions. But yeah, roots and zeros are the two that are kind of like exchange, like interchange the most often. How would I find the intercepts to? What form of a function lends itself most to finding the roots? Factored. So you'd have to look at these and see if I factor these, which are the ones that gives me, it looks like here, this is x is 5, and this one is x is -2. I guess what I would do is, well, if I know that that's where it's going to cross, right? So, I mean, I'm looking for something that, in fact, oh, look, probably even, here, let's do it this way. It's probably even easier. So that way we don't have to go one by one. If x is going to be equal to -2, remember that when we solve by factoring, we use zero product property. We make each factor equal to 0. If I were to bring this 2 back towards the x, because I want to make it equal to 0, what would I get? I would get x plus 2 is 0. On the x equals +5, if I were to bring the 5 back over so that x minus 5 is equal to 0, what that tells me is that my two factors should be x plus 2 and x minus 5. Some people look at that and say, oh, mister, you just changed the signs? Yeah, kind of. You know, if x is -2, look at the factor x plus 2. If x is 5, look at the factor x minus 5. And now that I have this, now I would just FOIL. And then once I FOIL, I can see which one I get. When I FOIL this, I get x squared minus 5x plus 2x minus 10. And when I combine my terms, I get -3x minus 10. So which one is it? Yeah. That'd probably be the best way. Another way you could have done this, now you could be a little sneaky here, and I can't guarantee you this would work, but you also could have looked for the h of the vertex if it's so quick. So like roughly, I mean, I don't know where this is with y, but you just saw on that first example we did that it takes longer to find the y of the vertex, the k. But if you look at the h appears to be where, like let's say 1.5, right? And it looks to be around like positive 1.5. So I could look at all these. See, all the a's here have 1. This is a 1. There's a 1 in front, a 1, a 1, a 1, a 1. So if you remember that h is equal to -b over 2a, really I just got to see, since all of the a choices are 1, I just got to look at all the b's and see which one of those, if I change the sign and divide by 2, should give me somewhere around 1/2. Well, 3, if I get this -3 and I change it to +3 and divide by 2, that gives me 1.5. If I were to change this positive to negative and divide by 2, I would get -1/2. I know it can't be that. This will give me -1/2. It can't be that. This one would give me positive, but positive 5 divided by 2 is 2.5. 2.5 is over here. I know it can't be that either. You can kind of be sneaky that way by looking at the vertex. If you have questions, let me know. Which function shows this function being translated 5 units to the left? On a horizontal translation, what do you look for to see that it's going on? Like physically, what type of symbol do you look for? It starts with P and ends with parentheses. Yeah, is there anything left or right? Translating left? Translating left to right has to be inside of a parentheses being added or subtracted, but don't forget the signs are going to be opposite when it's going left to right. So if you think left and you think negative, but no, when you go left, you see a plus. So which one of these have the same 3 to the x, but now has that x inside of a parentheses being having 5 added to it inside of a parentheses? What type of translation is occurring in A and D? Yeah, those are vertical translations. Select the range for the function. Now, I wish they would have had arrows here, but they don't have arrows. But what does it appear? Well, first of all, what type of function does this appear to be? It does appear to be exponential. And what appears that is happening to that left arrow? It's reaching an asymptote. Sure, it looks like it's leveling off. And then what does it appear is happening to that arrow? It's going down to negative infinity. Range means what are the y's doing? So how high and how low? And we go from well, this is interval notation, so we actually have to go from low to high. How low is this going? Negative infinity. How high is it going? To -1. Is it touching -1? Not if there's an asymptote. So which one of these says negative infinity to -1? Right, Kiara? Had a nice little stretch going, like, is it 3 days on a row with your head down? Oh, not yesterday, because yesterday you were taking. Given this function, determine if the function models a growth or decay, and then what is the growth or decay rate? Okay, let's go with the first question. Is this a growth or decay? How do you know it's a decay? The base is less than 1, so we know it can't be a growth. And now here comes the trick question part. What's the rate or growth of decay? This 0.64 is, you can call it a growth factor, because we know that when you have an exponential function, you're multiplying to get from one number to the next. So even though it's a decay, you can still call it a growth factor. But if they use this word rate, remember that the formula was 1 plus the rate. In this case, it's the negative rate because it's a decay. But that rate is what we're going up or down by, how either above or below 1 this is. So the rate is not 0.64. It's actually a 36%. Every new cycle, it's losing 36% of what it had before. It's retaining 64% of what it had before, but it's losing 36. Did you get that one right, Anna, or you got that one wrong? You got it right? Okay, good. Very good. That one even, like, I didn't get it wrong when I did it, but like I had to like look at it again. I had to do kind of a double take when I did it the first time to double check that word. So look at the functions. Which transformation makes f of x less than g of x? Okay. This is a really good question. This is like a higher order thinking question. It's more just understanding the way that the functions look. You don't even have to really, I'm going to draw them for you so you can see it, but it's more just understanding it. What type of function is f? F is not exponential. It is quadratic. What type of function is g of x? Yeah, this is exponential, and if you want to be more specific, it's an exponential growth. Okay, so if I were to draw each one, the quadratic one is an upward-facing parabola. It's actually the parent function. There's no transformations there. And then this other one it has an asymptote and it looks like that, right? Now, when they say f of x less than g of x, what they're saying is like, as far as the y's go, okay, which one of these transformations would make this parabola flip underneath the exponential, which is possible because a parabola has a change of direction. It's either all above or all below one point, and an exponential has an asymptote. It's only going to go as low or as high as something else. Right now, where is the asymptote for the exponential? At y is equal to 3. This x squared, how low is that going right now? It's going as low as 0. But the vertex of this right now is at 0, 0. So if I were to draw these one on top of the other, it would look something, like this for right now. But what can I do to get the parabola to go below the exponential? Oh, I flip it. Because if this is, let me draw the graph for you. My parabola is doing this right now, and the exponential, and the exponential is doing that. If I could get this thing and flip it, the vertex is still going to be at 0, 0. But now since it's going down, it's going to be entirely below the exponential. Which one of these has the parabola being flipped on the x-axis? Which one of these transformations means an x-axis reflection? Where you put the negative out in front, huh? B, very good. Yeah. A, we really haven't talked about. That's a horizontal reflection. If you get a U and you flip it horizontally, it still looks like a U. It looks exactly the same. C would be a shrink, but the vertex wouldn't change. The parabola would still, part of it would still be below, but then it would still have parts that are above it. And then 2 is a stretch, which again is not going to help you. If you want the entire parabola, if you want all the y's to be below the x's, you got to flip it. I mean, all the y's to be below the exponential, you got to flip it. Yeah, this is I just told you the part A, we really haven't talked. When you put the negative inside of a parentheses, that's not a transformation that we've discussed. But whenever you get to it in Algebra 2, that's a horizontal. That's a y-axis flip. If I get this parabola and I flip it on the y-axis, it's exactly the same. Yeah, you have a little part of it that's underneath the exponential, but if you want the entire thing, you gotta flip it. Any questions there? A table of values is shown. Which statement compares the graphs of f of x and g of x over the interval? The graph of f of x always exceeds the graph of g of x. Oh, this is what you were asking for. What does the word exceed mean? To exceed means to go beyond. In this case, in this context, it's being used as bigger. Okay, is f of x always bigger than the g of x that it corresponds to? Are all of these numbers always bigger than all of the? If I look across and compare, are all the numbers on the left bigger than the number on the right? Not all of them. Not until the end there. At the end, it flip-flopped, and the g of x got bigger. 29 is bigger than 25, so it can't be that. The graph of g of x always exceeds f of x. Well, no, that's not even close. Okay, the graph of g of x exceeds the graph of f of x in between 0 and 4. When they're talking about this, these are the x's. Intervals, we're talking about x's. So between 0 and 4, so up to here, which is where something changed, C is telling you that g of x is bigger, and then at some point they flip-flop. Well, no, it's the opposite of that. From here to here, f of x is bigger, and then somewhere in between these two numbers is where it switched, because then all of a sudden 29 is bigger than 25. So it would be D. Exceeds mean is greater. So here's another way I can, maybe that's cluttered. What's bigger, f of x or g of x? F of x. What's bigger, f of x or g of x? F of x. What's bigger, f of x or g of x? F of x. What's bigger, f of x or g of x? F of x. What's bigger, f of x or g of x? F of x. What's bigger, f of x or g of x? Yeah, now all of a sudden g got bigger. So somewhere in between these two numbers, somewhere in between 4 and 5, which is what it's saying, at some point in between 4 and 5, then they flip-flop. And now g of x is bigger. Look at the, oh look, this is kind of like what I just drew. But it's asking you something else. Which transformations would translate each function so that both would pass through 0, 1? Okay, so p of x is the, looks like the exponential. This is the exponential p of x, and then h of x is the quadratic. What can I do to the parabola to get it to pass through 0, 1? What can I do to the parabola to make it pass through 0, 1? We'll move the entire parabola up, sure. If I move the parabola up by 1, then that vertex is going to pass through there. Meaning it's a vertical translation up 1. Which one of these has h of x going up 1? Out of these transformations, remember, if you're going up, it's not in the parentheses. Which one has it going up 1? E. And I actually think that's enough to answer the question, but let's check and make sure. On the exponential, right now, it's not touching 1 at all. But if you look right above this, it is crossing the y-axis at 2. So if I could get it to, if I could get the entire function to drop 1, including the asymptote, well, then it would pass through 1. And that's what this is saying also. The minus 1 on the outside means it would go down 1. So it would be D. Parabola up 1, exponential down 1. Right, Caleb? You want to ask Kiara to make sure she agrees? What's another word for average rate of change? Slope. So they want to know what is the slope when x is negative 1 and when x is positive 1. So what is the slope between negative 1, 5 and 1, negative 1? Subtract the y's on top, subtract the x's on the bottom. 6 over negative 2 is negative 3. You got lucky. I should have made that one. I should have made that one short answer. I should have maybe typed that in. I left the multiple choice. I don't know why I did that. I think of all the ones I'm going over, the best one of these was like 44%, something like that, maybe. So these were all missed by more than half of you. The axis of symmetry of a parabola does not always contain which point? Okay. So remember, parabolas are symmetrical. It always has to pass through the vertex. So a maximum or minimum? No, because a maximum or minimum means the vertex. It has to pass through that. It has to pass through the vertex. So at the very least, you should narrow it down to these two. Okay. If you wanted to be technical, I could argue that both of these are correct. They're not supposed, like the one they wanted you to put was that. Because the y-intercept has nothing to do with an axis of symmetry. This thing could be crossing over here and the axis of symmetry is there. Like that never has anything to do with it. Unless the vertex happens to be the y-intercept. The only way that could occur is if the vertex is the y-intercept. And then the axis of symmetry will pass through it. If the vertex is right on the y-axis. Can anybody tell me what argument I would think of though to make that not true? Because it's saying the midpoint of the x-intercepts. That's usually true. But there is a counterexample. Does a parabola have to have x-intercepts? No, so I can make the argument, which of them is not always true? Well, I mean, if I have a parabola that's up here, guess what? There are no x-intercepts. So, I mean, I can make the argument now of the two. If like I wish maybe this would have said which best answers, because of the two, yeah, D is the y-intercept has nothing to do with it. But assuming that a parabola does cross through the x-axis, somewhere, like if we have some type of graph, and this is actually, I think Khan Academy teaches you to find the vertex using this method. Wherever the x-intercepts are, whatever's in the middle of that, yeah, the axis of symmetry is going to go through there. Because the parabola is symmetrical. It's always, the axis of symmetry is always going to be equidistant. But again, I could make the argument that C is also, incorrect just because they said does not always, and a parabola will not always cross the x-axis, but in the nature of the question, it was supposed to be D. I don't think any of you guys got it wrong because you overthought it. How you doing, Shobi? What is the average rate of change on the interval -3 to 1? So these are both x's. This is x1, this is x2 when you give intervals. We did this together. At -3, what's y? What's y at -3? Look, it does look like 9. At -1, it's 3. What does average rate of change mean for the second time? Slope. So slope is just 9 minus 3 over -3 plus 1. Which is 6 over -2, which is again. What is the average rate of change? So again, another average rate of change. But okay, this one requires some substitution. So let's first evaluate f at 8. If I plug in an 8 divided by 4, that gives me 5 times 2 squared. 2 squared, we have to follow order of operations, is 4 times 5 is 20. So I know the point 8, 20 is going to be here. If I plug in a 12, f at 12 is 5 times 2 to the 12 over 4, which is 5 times 2 to the 3. 2 to the third is 8 times 5 is 40. So the point 12, 40 has to be there. So now when I find slope, 20 minus 40 over 8 minus 12 is -20 over -4, which is +5. What is the asymptote? Okay, this one's real quick. If they give me the function, where would I find the asymptote? It's well, we don't, could you even call it K? Yeah, it would be K, that's exactly right. Yeah, what's K here? What's being added at the end? Yeah, nothing. But now don't get it confused, remember, it's horizontal. Because it's horizontal, y equals 0. Asymptotes are imaginary lines. Can anybody tell me what is the imaginary line that we've talked about? Even today we talked about that's vertical. There's one type of imaginary line that's vertical that we talked about even today. Axis of symmetry. What is the y-intercept? Okay, this one should be easy. Any function. What type of function does this happen to be? Yeah, this is exponential. It doesn't matter. It could be linear. It could be quadratic. Any type of function. If you want to know one intercept, put a 0 in for the other variable. So if I want to know what my y-intercept is, put in a 0 for x. What's any number to the 0 power? 1. 1 times 2 is 2. That's a short answer. For the Google Forms, just put in 2. I tried to program it to accept y equals 2, but I can't promise you that it will accept it. Which of the following has a look line of symmetry? We just talked about that. So these all are parabolas. 2 of them are drawn. 2 of them are functions. Which one has an axis of symmetry at x equals 2? Well, we can look at the graphs. There's no way this one does. This is on the negative side. So is this one. So it has to be one of these two. Yeah, you can go through all the trouble of finding the vertex. Oh, actually, I guess you wouldn't need the vertex. You could just do the h. You can find h, and if h gives you 2, you'd be right. But I can already tell this is in vertex form. It's going to be that because here my h is positive 2. Remember, if you see a negative 2, that means that h is positive 2. What would h be for answer choice B if you did want to go through the trouble of finding h? What would h end up giving you for answer choice B? Which function has its vertex below the x-axis? These are all quadratic. We just talked about an example of this. So they want to know which one of these stays everything. Well, actually, you know what? It has a, okay, so now you know what? This could either look like this, or it could look like this, either one. Because it's only talking about the vertex. This vertex here for D is at 0, 8. Because there's no B term, so I can treat this as vertex form. What's the vertex for answer choice C? Negative 3, 0. Good. That's not below the x-axis either. What's the vertex for B? 0, 0. And then this one here is at 7, 0. Is it none of these? Which one has its vertex? Oh, because I thought it was positive. Thank you. I couldn't read it right. Thank you. Sorry, this is 0, negative 8. I don't know why I saw that as a positive. Yeah. So it is this. To be more specific, if you were to draw this, it would be up facing, and the vertex. This is one of the ones where the vertex is on the y-axis. It would look like that. 2 more. Which of the graphs below represents this function? What are the key components you would look at? You can look at the x-intercepts, and you can look at the vertex. I'd probably go with the x-intercepts here. Is that a negative in front? Okay, well look, the A is negative, right? So we know it can't be these two, because those are facing off. I'm not even going to waste my time with those, because there's a negative in front. A is negative 1, B is negative 3, and C is 4. We also know that this C is also the y-intercept, so I would look to see which one's crossing at 4, but they both are. You know what? Let's do it by vertex instead of having to worry about, because I don't really feel like factoring with that negative in front there. It could be done. I'd rather not do it. Let's just look for H. Negative B, so it would be then positive 3 over 2 times A, which is negative 1.5. Which one of these has a vertex on the negative side of X? And finally, determine which graph matches the characteristics. So this is going to be kind of the same thing. This one has a negative A. A is negative 1, B is negative 4, and C is 5. So it has to be facing down. It can't be A or D. The y-intercept has to be 5, but it looks like both of them are at 5. So let's just find h. H is negative b, which is positive 4, over 2 times negative 1, which is ends up giving you negative 2. It has to be b. Any questions? We'll have another practice test tomorrow and keep on going through the drills.